Hello, my name is Gautam. I'm a part of the CS 5330 class for Spring 26. This is my video submission or video report for assignment 3. So we were supposed to implement a real-time object recognition system, and here's my setup. I'm using a webcam, and this is my a white platform or the white background that I'll be using. And I've used a normal LED bulb, and to avoid the black flickering lines on the white background, I've reflected off the walls and the top of the uh, and the ceiling. Okay, and I will start the demonstration here. So we run the program by passing a CSV file to the binary, and then the video has started. And on top, we can see that when the system is unable to recognize the system, it shows it as unknown. In this case, there is nothing, and it sees the whole frame as unknown. And as we see here, it's trying to create segments from what it is seeing. So I have, so you can choose to load vectors and features from the CSV file. And before recording this video, when I was trying out the system, I have already trained it on about 5 objects. So I will show them one by one. Here we go. This is a ladle, right? And I place it in the field of view like so, and then it picks it up and labels it as a ladle, as we can see at the top left corner here. And then next we have a comb. It's a standard comb, and then my system is such that it can detect multiple objects in the field of view. So if I were to place the comb along with the ladle, it will successfully label both of them as displayed. Okay, and then I have it can detect more than 2 items too. So take this clip for example. I have already trained the system on this clip too. So if I were to place it here, then it recognizes that also. And then we have a clock, a standard clock of a distinct 2D shape. And if I were to place it here in the field of view, it would successfully pick that up also, right? So this is quite interesting. And then for the fifth object, if I were to move it slightly to the back, are we still having all four? Yes, we still do. And then finally, I have a hammer of this. So the challenge here was the shiny portion here, right? That was a difficult bit. And then if I were to place it here, it says unknown for now because it is not able to actually, because the whole object is not within the field of view. So if I were to move if I were to take out the comb and move it slightly further inside, and it successfully labels it as a hammer. So I have figured out, I've used 7 features, PF being percentage filled, AR being the aspect ratio, CO being compactness, CR being circularity. Then we have the first 3 hues coefficients, and in the end I've also displayed the angle. So this is the system that I have designed, and this is the scenario where it is successfully identifying the objects that it was previously trained on, and I have not given it more than 3 images uh, per object. So let's save this image where, so we will be saving all the 3 images that lead up to displaying this. So if I press T, it toggles the threshold view mode. So we can see the binary image that the thresholding algorithm that I have written. I have used the k-means to implement a dynamic threshold, and then I perform morphological filtering on this object to kind of smoothen out the surface, smoothen out the white region, and then post that I draw the outlines, and I draw the primary and the secondary axis through the centroid of the image, or the region rather. So I will also show that the object can successfully uh, distinguish objects that it has not seen earlier. For example, if I were to take this hammer out and then place this light, it's a cycle light, If I were to place it in the center like so, it would just say unknown. Right? It has a distinct shape. If I were to place it any which way I wished, it would still not pick that up. This way, nope. Even if I were to move the rest of the objects any way I wished, the other objects are still being picked up successfully. So if I move it closer, slight overlap, it's still able to successfully pick it up. That's a good binary image. I will save this too. So it is able to successfully tell what it has not seen before. We can take another example with a simple Allen key, where if I place it here in the field, it is trying to pick it up, but it's only seeing a portion of it. But let's move it around so that it can better find it. Now it is unable to see the clip. This usually happens due to the light. It's not a professional quality photographer's light, so usually changes in like slight variations cause it sometimes make uh, regions go unnoticed, and it happens very occasionally. And we're back. We have a clip, ladle, and this Allen key is being falsely labeled as a, I think it's being labeled as a hammer, right? So for the sake of experimenting, I will uh, uh, train the system to label that as a hex key. Okay, so here I will take the rest of the objects off, and yes, training with multiple objects in the within the field of view is possible, which I will show you very shortly. So let's simultaneously try and train for this, for the light, and for the hex key that's already in the field of view. So I will place this to here in any random orientation, and I will press N. N is the key for training. So it displays a small, a selected, a filtered out image of the portion we're trying to label. So if I want to add this label, I press A, and then I need to go back to the terminal, and it shows me what the available labels are. And so hex key being is not one of the available 5 labels. So I will enter a new uh, label. I'll type it as hex key. If I press enter, it asks me whether it's a new label or whether it's a typo. So it is a new label. I press yes, and then we go ahead, and then it has successfully noted down the region as a hex key. And then next, immediately it shows the next object that it wants us to label, and I want to add this label too. So I press A, and then we go back to the terminal, and as we see here, there's another extra um, label that has been added that was not here earlier. That is the hex key. So is it one of the above? Is it one of the available labels? No, it is not. So we will add this as a light. Sorry. Let's just add the bike light. Right. Press enter. Is this a new label? Yes, it is. And then so yes. So for the purpose of calculation, I also use I've used scaling so that no single feature overpass the rest. That's why I calculate the standard deviation. It means every time we add new training data. So we can go back to the our program, and here it's correctly showing us the new labels. Now let's try and move them around, and it's still identifying it correctly. Let's move the hex key to the corner. Yes. So usually this problem occurs mostly due to the way the light is set up. So usually in the corner, I've noticed that further towards this corner, uh, objects are not picked up very accurately. So let's see if it makes any difference. Yeah. So if you move it up, it stores it as a hex key, right? And then if I were to move it further down, sorry, that's out of the frame. Here, it successfully labels it as a hex key. Let's move it here. It's let's try and analyze why it is not picking up the hex key in this particular position. If I were to go and press T to view the uh, threshold image, we clearly see that the region is too small and it's being filtered out and it's not being picked up, right? And this again is partly due to the way light is being reflected. If we see it clearly, this particular region is pretty bright. The light is being reflected off this region, and hence it looks nearly of the same color as the background. If we move it around slightly, it still sees it as a. I'm unable to see it. Let's just change the color. It still sees it as a hex key. So I guess it still falls within the threshold, although it is flickering between unknown and hex key. So let's train it on in this region where it is hammer, right? So it's falsely seeing that as a hammer. So let's train it again. This I will, well, I can skip this for now. So I will go ahead and skip it by pressing the letter K. I'll label the hex key by pressing A, add label. Now I navigate to the terminal and I say hex key. And now I have, now I can go back, and in the image it will be displayed as a hex key, obviously because the position has not changed. Let's see if I were to put it in a region where it was. Yes, it still shows it as a hex key. The idea that I came up with is with, since the camera and the background are stationary and only the objects in the field of view are changing, I came up with another thresholding method. It's quite simple. It I, I I call it the like sub thresholding by subtraction. So if I press 1, because it's mode 1, uh, so it asks me if this background is satisfactory. I think it's quite satisfactory, so click yes. And then now, so we've basically captured the background, and anything that comes over it will generate some difference with the original background. And that's how it immediately catches that there is an object on the surface. So the same hex key, the same light, nothing has changed. It should be detected more often than it was previously detected. There you go. Successfully labels it as a hex key. Hex key. However, here it sees it as a ladle. Let's give it the whole. It's varying between hex key and a ladle. Hex key again. Let's move it here. Hex key again. Here it was shining quite brightly somewhere here. Yes, it still sees it as a hex key. Hex key. Me putting my hand in the way has no effect on it. Hex key. If I were to still block the light out, if I were to block the light out, the whole reflection from the background would change, and hence, as a result, it would still spot a lot of other regions, apparent regions. But yeah, so this is a method I came up with. For example, if I were to go back to mode 0, which is using dynamic thresholding, this object immediately disappears, because this shiny part, again, if I were to place my hand here, it picks it up, right? So this is a problem that I was facing for objects such these such shiny objects such as this, um, excuse me, and such spanners. So this too isn't picked up, because it turns out if we see the thresholding image, it's actually quite bright, and although it sees it as a, it does see it as a foreground, but it is too vast, and that's why it's picking up the whole image, right? If we take this off, um, so these such shiny objects were not being detected under these, under the setup that I have with the light, with the background, and maybe the ambient light coming from the window or from my laptop affects it. and there was no fixed way to have very certain or fixed testing conditions. So that's why I came up with the background subtraction thresholding method. And it turns out that I can use not just a white background, I can use a black background as well. So let me show you how that works. So if I were to take this and just place it in the field of view, right, now this becomes a new background. Uh, so now all we have to do is we need to go into the subtraction thresholding method by pressing 1. Okay, so it sees that there's a lot of change, but I can recapture the background in this case since the color of the background has obviously changed. So I can do that by pressing W. So it asks me, am I satisfied with this background image? I say yes. So this is the stored background now. Now these very same objects under the same light conditions will be detected. Should be detected. Let me see. That's weird. Okay, there is the spanner, which is shining quite brightly, is being picked up. And let's see if this object, let's see why this is. Well, let's take these two off. Okay, we are again. There are slight variations, there are slight continuous variations. Um, let's go back to this and let's recapture the image for that matter. Let's just say yes. Now let's see thresholding image. Now it's much better, right? Probably I disturbed it when I was placing this. So let's see the original image. Now rather let's keep the thresholded image and let's see if this is seen. Oh no, it's not picked up again. Now it's picking up, yeah, now it's picking it up more distinctly here. It's probably because the light is turned towards this side and there's probably a stronger uh, there's more luminescence in this region as compared to this, and that's probably why it is happening. So I guess against a dark background, shinier objects might be detected better in the region that's first slightly further away from the reflected part. And I think let's try and train it, and let's. So the experiment that I'm trying to showed in the during the demonstration is that an an object that I train on a dark background should be identified elsewhere as well. Okay, so let's try and train this. So I will skip this, or I will go ahead and train it either ways. Um, let's add the label. We will add it as a clip. Now we go back to this and we'll try and add this also. We'll add the label and we'll say this is a hex key. Add it. This worked. And now this object here. And then now I'll type this, input this as a spanner. Is this a new label? Yes, it is. And then that's, and now it's identifying it as a spanner. Now let's try and move it around. It still sees that as a spanner. That's good. Still seeing it as a spanner. That's very nice. Spanner, hex key, clip. Let's just train it once again. Okay, there's a little bit of reflection in this region. I'll save this image and I will also train. I'll skip this, pressing K, and I will add this label. Go to the terminal, type SPA spanner. Yes, that's it. And we go back and then I can train this as well. I just do add label, and then I type this as a hex key. So that's that. So it's still being seen as a spanner. So all's good so far on the black background. Um, so we can take these off for now, and then let's try and see if the original objects are being detected. The ladle, yeah, the ladle's good. The ladle's fairly easy on any background. It's a plain object. Let's see if the clock is being detected. It says it's unknown. Let's try and put it in slightly darker region to avoid the glare. Let's see the thresholding image. And the morphological image. Yes, it's probably difficult for it to see it because of the excessive reflection. This will be probably very difficult here. Let's put it here. Okay. So this for the it was quite difficult to predict the clock, especially because it has the white insides. So again, this too is reflecting very strongly and creating a different 2D map than what it was expecting. I don't think it's accurate to train the model on this either. And let's take this this thresholding method up a notch. So instead of using a regular dark background, I will use a irregular image like so. This is an image of a Su-30, and I will use this as a background, as you can see in the image. So if I place it accurately in the center, somehow, right? So we are still in the subtraction thresholding method. So I will press W in order to recapture the background. So I select yes. So now again, nothing's being detected. Now let's take a simple object such as this, a clip, right? Let's place the clip right here. Yes, and that it picks up the clip fairly easy. Part spanner and clip are approximately seem like the clip seems like a scaled down version of the spanner's dimensions. Probably that's why it is seeing it as a labeling it as um, a clip, labeling a clip as a spanner. It still sees it as a spanner. Apparently, yeah. Now we have a clip. So they're really close, I suppose, and that's why the variation based on different regions. Maybe the thresholding image can tell us a different story as to why this is happening. Let's see what this says. It says a clip. Now it was showing. This was saying a spanner. Yes, this is slightly probably due to the reflection again, as you can see here that it is not very. It does not hug the boundaries of the clip, and there are some kinds of reflection along this edge, and that's why it probably sees that as spanner because it grows the size of the two-dimensional map. So going back, let's perform. So as we can see, we are able to detect certain objects, able to detect quite a few objects. Okay, this ladle is rather difficult because it's kind of big and it causes the background to move a little since it's paper. It causes slight variations and that causes a difference in reflection. If I were to just place the comb here, so this too is most likely causing variations. If we were to see the thresholding image, yes, this has changed the background quite a bit. So if I were to gently pick this up, we would go back to most of it being the background. Let's try smaller objects for that purpose. Let's just try the bike light. It's able to pick it up, but it's also causing some differences in the background. Let's try the hex key. Yes, it's able to pick it up. That's pretty good. Now we have this. It's a equilibrium tool. Let's try if we can do something about this. Similar to a comb. Um, Do we have anything else? No, I suppose this brings me to the end of my demonstration. So again, if we see the thresholding image, the slight variations compared to what we expect. We're not getting a very strong fixed boundary even through the morphological image, and that's probably why we're seeing a bounding box that's bigger than the actual size. So if I were to reflect, change the light amount, but the whole thing would change, right? Let's see if there's any particular orientation it can pick it up. No. All right, it's not able to pick up the equilibrium tool against the varying background, especially mostly because of the light. The way light is reflecting off the walls and the way the background changes whenever you keep something big on it. But let's try if we were to take this background off, right? We were to take this off, and then we can recapture the background. Um, Notice how there's a tape in the middle of the page, and uh, right, there's a tape here, and if I save this by pressing yes, it will not pick it up right now. But if I were to place a white piece of paper that's of the same color as the rest of the pages, it would detect a region there because it just disappears, right? If we were to see the thresholding image, that's the only region that's actually changed. So that's kind of a cool feature of this thresholding method. So if I can just place this and recapture the background um, by pressing W and yes.